Okay, everybody, we want to do glaciers today, and keep in mind that this kind of references back to our chapter on mass movement, but also rivers, because glaciers are mostly just rivers of ice, and they will change the landscape. And so those processes are something that we're going to be looking at in this lecture. So again, there's stuff up on the weekly chapter module on Canvas. So make sure you watch those animations because they will show you how these processes work in more detail. So basically, glaciers are just they're very slow moving rivers of ice, and they always form in areas where we have permanent snow. And the gradual accumulation of snow, it recrystallizes under its own weight and then moves under pressure of that weight and the pull of gravity. Now, currently, glaciers cover about 11% of the Earth's land area, and that's mostly going to be found in Greenland and Antarctica. Although during the past ice ages, around 12,000 years ago, they covered as much as 30% of the Earth's land surface. So you can see this. This is just like a river of ice. And notice the tributaries, just like we saw with rivers and streams. You have tributaries for glaciers, and then basically the weight of the glacier is pulled down by gravity, so it will move down slope. Now there's all kinds of different uh, ways and structures, erosional structures that landforms that are glacier related. And one of these is what we call a cirque, these bowl-shaped erosional landforms scooped out at the head of a valley, kind of like up here. Valley glaciers, where the glacier is confined to a valley, Piedmont glaciers that spread over lowlands at the base of a mountain range, and then the tidewater glaciers that end in the sea and calve off and form icebergs. We see these in Alaska and Antarctica. So you can see here, so here's the head of the valley, and there's your cirques, and that's where the glaciers will originate. And then they'll be pulled down by gravity. Here you see the Piedmont Glacier where it spills out into the lowlands here. And here's the Tidelands one where Tidewater one where it meets the sea and calves off into the ocean, and then this will form the iceberg. I think I got some videos later on of this. Now, continental glaciers are ice sheets, continuous massive ice, 81% of Greenland, 90% of Antarctica. The weight of the glacier will press down on the land, and that is called isostatically depressed, meaning that the land is pressed down by the weight. Now, glaciers work on mass balance, and you get an upper accumulation zone where the snowfall and moisture collects and compacts into ice. And then you get what we call the lower ablation zone, where the internal and external melting of the ice occurs. The glacier melts at its base. Wind is active on that. You get ice blocks will break off, and sublimation, where you get the change to water vapor. At some point, you get what we call the equilibrium line, the dividing line between accumulation, what we call ablation. And so the glacier will start to retreat or advance. And this depends on its mass balance. If the accumulation is greater than the loss, then we grow. If the loss, the ablation, is greater than the accumulation, then we get decay. And again, you can get ablation through climate change, and as the temperature warms up, as the atmosphere warms up, glaciers start to melt and they start to lose their mass and they will decay. So here's your accumulate. So this is in your book, so pay close attention to this. So here's your accumulation zone where the snow builds up. It's compressed by its own weight. Okay. And then notice the tributary glaciers here. They flew into this. As it moves over the land, it's just like the rivers abrade the stream bed and the stream sides. It's the same thing here. As the ice moves over the ground, it will abrade the surface and pluck rocks off and carry them along in the ice. Now, eventually, the glacier will start to lose mass through melting, and other processes. And that starts right about here in this example. And so the glacier will start to retreat. Its terminus is what we call the moraine, the terminal moraine. And so all this material that's been brought down is deposited here. And as the glacier retreats, it's leaving material on the ground, but where its furthest extent, that is what we call the terminal moraine. Okay, so we'll get on to glacier movement on to the next one, okay?